Where's Charlie? Oh, there you go. Wait, you left? Everyone, you left?
I went to
Oh, never mind. We didn't have to. I read it once, I was like, but the way
Special act.
Okay, I'm going to get started. So I'm going to give a presentation on the bill of materials and cost report. As I hope all of you know, this is a big deal. It's a lot of work, and the deadline's coming up quickly. I tried to get everything in here, but if you have any questions during the presentation, go ahead and raise your hand, and I'll have time for questions after. I was going to do a live demonstration, but I decided against it because it would just take a really long time and be really redundant. So I'm going to go kind of slow. Hopefully I don't bore you guys too much. And I guess let's do this thing. Okay, so basically why all you guys should care about the cost report is 10% of the competition points is in this report. That's a lot. It's definitely the difference between third and first is 100 points. So it's also mandatory to turn in. If you don't turn in, you're disqualified. And also, doing a BOM, a cost report, and balancing costs is something that you do in industry a lot. Engineering and cost are not separate. They're very intertwined, and it's very rare for you to have a job where cost is not more important than performance. So, so what is the cost report, BOM? It's a comprehensive list of everything that has to take place to build one car. So that's all the materials, that's all the labor, and this includes everything from nuts, bolts, zip ties, down to the labor to cut the zip ties, to tighten the bolts, to pick things up and place them other places. That costs money. And it's a lot. And it's not something that should be done by a few people. I have unfortunately had that experience twice. So I'm giving this presentation because I'm not working on it this year. And it shouldn't be as bad as I hope I scared everyone that it's going to be, as long as everyone puts in the work. And everyone's on the same page. So here's the hierarchy of the BOM and the cost report. So it pretty much has 3 levels. The full assembly, which is every sub-assembly. It has sub-assemblies, which are pretty much broken down into the sub-teams that we have. Then it has components within those sub-assemblies. So a lot of you probably have 1 or 2 parts you're going to be responsible for. So you're going to be mainly at the assembly level. The way I'm thinking it will probably go is sub-assembly level will probably be your guys' team leads. And then full assembly will be, the business guys making sure everything's in there, making sure it all looks good. But, Tanner, Alex, Ray, possibly myself, we'll see. We're not going to go in and check to make sure all your stuff's right. So if you leave something out, that's points that we lose. So in the rules, it breaks down how many points you lose for each violation. So if you forget to add 1 bolt, that's 1 point. And you know that adds up quickly amongst all of you guys. So it's really important that we get this right and accurate, and that it gets done. So I'll start from the assembly component level. So what goes in this level of the BOM is all the material and processes that it takes to make that part. So this part could be a part that we machined, it could be, you know, a part we did in composites work, whatever. All the costs for making that part go into that level. And then all of the fasteners, you know, bolts, nuts, pins, whatever, also go in that level that that part needs to be held on to the subassembly. And then also all the costs to assemble that part into the subassembly go into the bottom layer as well. So this is where most of the stuff ends up going. And this is where most of you guys are at. So this is all kind of abstract now, but I'll get into specifically what each of these levels mean. Moving up, you have subassembly. So that's going to be your system. So uprights, you know, you have tons of components within the upright, and all that gets assembled into the wheel hub assembly. So what goes in there is going to be the cost to assemble this whole subassembly into the full assembly, and all the fasteners that subassembly needs to be mounted to the full assembly. Yeah.
And by the cost of assembling, you mean like the labor that actually goes into it?
Yeah, so that's like tightening bolts. That is, you know, based on the weight, there's an assembly price, and I'll get into that. So, like, we'll get into it, but yeah, that's all the costs for, you know, cutting zip ties, tightening bolts, those kind of costs. That's the assembly costs that I'm talking about. So how we get there is we go to fsaonline.com, and when you click activity menu, this is the screen you get. So this is for yours will say Highlander Racing EV, unless you're going to the IC car, but right here, online cost report system, this is where you're going to go for your first step. And when you open it up, it's probably going to be blank, but IC cars looks like this. So, you know, we have different vehicles. So IC cars is this bottom one, and it's pretty much done because we did it last year. So if you're not on the IC car team, you can request access. And I can give you access, and you can look at ours as an example. I'm not saying all of it's 100% right yet, but you know, it's there to look at. So then if you go in and you click the Manage Cost Report button for the car that you're working on, you're going to get this. So these are all, so these cars are the full assembly. Once we get in here, these are all the sub-assemblies I was talking about. Then, you know, based on your subsystem, you're going to click Manage Assemblies, and you'll get into the final component part. So before we go into the actual, you know, filling out the BOM and cost report for your part, these are some general rules I'm going to talk about. So there's two types of parts on the car. There's parts we made, parts we bought. I'm mainly going to be covering parts we made, because parts we bought is pretty easy. You go into the list and you click it, and you say how many we have, and that's it. So, you know, if we can, that's why I personally always try to push, you know, parts, if we can buy it, like, rather than engineer it, it's much better. It's much better here, it's much better with, you know, we don't have to put work into that elsewhere. So, specifically for machine parts, you start off with a raw piece of stock, and on all faces, it has to be 0.04 inches larger than the actual part. So if you have a 3x3x3 you know, cube, it's going to be 3.08 times 3.08 times 3.08. And This is important because we'll get into getting the cost of all the material and machining and all that later. For round stock, that means that's 0.08 on the diameter, not 0.04. And we fill out this BOM like we are the most badass company that's ever existed. We have the best machines ever. We have the best tools ever. And pretty much that's because the judges can't check that. You know, this is our way of, cutting costs and getting more points. So for prismatic parts, this is things that are, square, triangle, some sort of polygon shape. They're going to require 2 machining operations in general. For anything that's round, we're going to say it requires 1 machining operation. All bolts that we're going to tighten use power tools. And for round parts, like large round parts with bores to the middle, there's such a thing as thick tubes. And that's pretty much just like a tube with 40 thou on each of the surfaces from the part. So we're really trying to minimize cost. And then only composites and welded parts get jigs or molds. Even though, I spend tons of time making fixtures for parts, that doesn't go in here. So really, if we just follow these, everyone should be able to do their stuff. It doesn't require, a lot of machining knowledge to do this, if you just follow these rules. So here's the example part we're going to do. And before I move on, I want to kind of address that this is how your design tree should look. If all the holes in here are not the bottom, it's going to be much harder for you to do the BOM because we need to calculate volumes without drilled and tapped holes. So if they're in the middle and they're referenced down below, you're going to have a hard time getting the numbers we need to continue on. So what you want to do is put all the holes at the bottom. If you need to reference holes, put sketches in and don't actually cut them. Because if we move on here, you can see that this is all the stuff we need from the part model. And once we have all this, it's just filling out the form. So first thing, if we notice in the model, it's mild steel. Second, it was squarish, so it's prismatic. And that means 2 operations for machining. Next is the part is under 1 kilogram, and that is the lowest weight for assembling. It's based off the amount of weight the part is for the assembly cost. So number of holes, regular length, which means that the hole depth is less than 4 times the diameter. They have 2 of them. The number of drilled holes that are over 4 times diameter, we have 3. And the number of holes that are over 8 times diameter, we have 1. So these different holes are going to cost different amounts because it's much harder to drill longer holes and shorter holes. Number of ringed holes, so these are like holes that dowel pins go in or that are press fit goes in, is 3. Number of tapped holes, so these are holes with threads in them, 2. Stock size, I went through and already did, so we didn't have to do that here. It's going to be 3.08 by 3.08 by 0.844. So using SolidWorks measurement tool, don't waste time calculating anything by hand. Just have the SolidWorks part open. Use the mass properties to get these numbers. Stock weight is going to be 2.273 pounds. Stock volume. So part volume without holes. This is what I was talking about. And the difference between those 2 numbers is going to be how much we actually machine off the part. So here's what the part page looks like. So this is going to be 1 part. So every single part on the car has this. So down to spacers, bushings, to uprights. And at the top, you can see that we're paying for the material. first, in the processes, you see we have the 2 operations for machining. The third one, you can see that it's machining the part, and that has a cost. And if you look over on this, you can see there's a multiplier. Because this part is steel, it's harder to machine, so it costs 3 times as much, which is the multiplier that's set. We have the holes, they have their multipliers, you know, tapping holes, ring holes. I'll show you later the cost tables. When you open up a specific process, it will list what the multiplier is. And there's a multipliers table, and you can go and see what all the multipliers are for that category. Finally, we have a 9. This is the assembly cost I was talking about. So because it's under 1 kilogram, this part costs, you know, 6 cents to pick up and place onto the subassembly. And then power tool here, so 6.35 millimeters, quarter inch. So this is going to be to tighten the actual bolts that hold it on. And then below here, we have the 2 fasteners that actually hold this part up. So this is what goes into every single part. So whether that's, you know, a sheet metal part, a composites part, a machine part, there's going to be one of these for every single person part. So if we split this up, it shouldn't take too long. The one thing the BOM really does is that it flushes out every single little tiny piece that's missing. You know, if you don't have bolts in your assembly, it's going to suck because you don't know what bolts you have. If you don't have nuts in your assembly, like, you have to stop, go find the nuts. You know, if you realize that there's a part missing that you know, oh, it's a simple part, I can do it later, you have to stop and do that. And that's where this takes a really long time. So if your assemblies are good, if everything's there, this should go quickly. And I decided to do a machine part because that's most of the parts on the car for most of everyone. So back when I first did this, there was no online system. And we had to make an Excel sheet for every single part. You know, it didn't have any of the formulas in it. We had to look up all the values in the tables. And you know, you had them memorized at that point. You knew how much each kilogram of aluminum cost. And it was so bad. And then we had one person just organizing all of the sheets. So you guys are really lucky that someone made this. And I honestly think it was a team who was so fed up with the Excel sheets, they made this and gave it to FSA International. So it's really not bad. You know, these are all text boxes to fill in. And you know, when you hover over these text boxes, it tells you exactly what it needs. So you know, this is for the how much volume we machined off this part. You click it and it says, you know, it wants cubic inches. And you just put in the cubic inches and it calculates it all for you. So it goes pretty quick. At the bottom of every single page, there's this ribbon here. And these are the 5 cost tables where everything is at. So anything that we buy is under material. Any raw material we do, material. Any wire, material. Any physical thing besides fasteners is material. Fasteners is the smallest one, and it's pretty, you know, there's bolts, there's shoulder bolts, there's pins, but you know, it's all based off formulas. And some of the formulas are absolutely insane, make no sense, but you know, you're just punching in values. Processes, this is going to be all the assembly processes, all the machining processes. To plan out how you're going to lay wire is a process. To crimp the end of a wire is a process. To solder something is a process. So every single action that someone would take is on this BOM. Like that includes zip tying wires, you know, putting tape around something. So this does take a long time if you don't have this all planned out already. Process multipliers are things like different materials to machine, different hole lengths, and there's some assembly ones as well for bolts that are like ridiculously long. And then tooling is going to be your welding jigs, your composites, molds, things of that nature. Those two are pretty much the only one in tooling that matters to us. So other types of parts, the example I used was a machine part. There's a lot of sheet metal parts as well. Lucky for us, water jet and laser cut are the same price, but they're based on the length around the part. So if you have a tab, you have to find the circumference around. And this adds up for all the tabs that you need. Welding is also based off the length of the weld. So when you have two tubes meet, you have to find that arc length of the notch tube. So like these are the numbers that take a long time. Sheet metal has its own processing for bending or stamping and all that. Composites, each composite part requires a mold. It's under tooling, lamination, and it's based off the surface area. There's one for flat plates, like dashboard or some back body panel or something like that. And there's stuff for curved surfaces, it's body pods, seat, everything else. And then there's rapid prototyping composites that does not apply. That's 3D printing carbon fiber, which we do not do. 3D printing is called rapid prototyping plastic, and it's just based off the weight of the part. Pretty easy. Electrical, this year is going to be a lot. IC car has a wiring harness, and it's $500, and that's all the electrical we have here. For this car, every single fuse, connector, wire, resistor, all the labor to trim the wires, to cut the wires, to heat shrink the wires, is in here. So battery, electrical subsystem, and anything else that gets power is going to suck. So a lot of people who, the mechanical people, if you have that understanding of, enough understanding, you'll probably have to help out with the electrical subsystem, because the 4 or 5 guys for the whole car is probably not going to be enough. Yeah.
So even though we're going to be hand assembling, can we get a quote for a fully assembled, manufactured board and just plug that in?
So the way that boards work is kind of weird. And so we'll go over that in more detail. But there's set prices for boards, but anything coming off those boards is going to BOM clipboards, and they just circle the car. And, you take the body off, and they can ask you to take anything apart so they can see inside of something. So every single point we lose is critical because it adds up. And it's crazy. So there's just 5 people from the industry sitting there just marking your car off. Yeah.
After that, so we don't wind up using outside quotes at all. They have everything standardized.
Yeah.
What we bought the motor for or the engine for the IC car is not the price that we put into there. They have a price for a 600cc motor or engine already in this. So everything's standardized. So like you're saying,
but as far as
and put it into there.
If you're talking about BMS, VCU, LCD display, that's in there and it's based off a set price already. So, but all the high voltage wiring, all the low voltage wiring, is going to be a lot. So, what if we bought a part and it's not on the BOM materials list? So there's a special form you have to fill out. We've done it before for IC car. I have an example. But because the AV car competition is so small and new, a lot of our stuff is not going to be on there. So we have to fill out this form quickly and get it in. It requires the description of the product name, a quote from the company for what we bought it for, and a picture of the product. And it takes roughly 2 weeks for them to add the parts in. So if you do the math, we need to get this in like really soon. So here's what it looks like. This is the one we did for the shocks last year. And you have the name, the unit cost, the unit. So if this is like, you know, if we were adding some special type of wire, this would be like meters or something. But the unit cost for this is unit, it's quantity. Cost type of MSRP is basically, you know, default there. You put the supplier, you put what we got it, you put what category it's in. So in each material has a category. So brake calipers are in the brakes category, and dampers are in the dampers category. If you include the quote attachment, you have to say yes. Date that we turn it in, mass, and then you want to put the link so they can find it and verify. At the bottom, you have to put the supplier's contact information so that they can call and verify. Here's an example of the quote we gave them. And what they do is they take the price you paid and multiply it by 75%. And that's because we're building this car like on a mass production scale. So they expect that you can get the parts cheaper than what you're paying for one. So the shocks are in there for $250 on the materials list, but we paid $325. So any parts that we bought that aren't on here, this has to be done. You know, and because we're getting close to the deadline, like, what do you do if they don't apply in time? So the best bet is find a part that resembles it and put it there as a placeholder. Make a note that it's not the right part for, you know, the judges, for us, so we don't forget to go back and change it. After we submit the BOM, we can change it in case, you know, a design changes, or, you know, we actually get the part added to the materials list. But for every dollar we add to the BOM, we actually add $1.25. So, you know, the score is based off how we do on the cost of our car relative to others. So our car may have been cheaper, but because we changed a lot of big components late, and in the end, we may have a higher actual competition cost. And then for every dollar we reduce, let's say we decide to go with a cheaper alternative for, I don't know, the LCD screen. We don't get all that money back. We only get 75% of that back. So we want to make sure we turn it in. Turning in the BOM late is 10% a day that we turn in late. The actual whole BOM has to be printed out, put in a binder, and shipped to SAE International. And if we don't turn it in, I think it's after 5 days, the team is disqualified. So this is a big deal. And, you know, we have to get this done. We have to get it done quickly. So does anyone have any questions, concerns? No?
When's the due date?
I believe it is early April, right? You know?
Did we, what's that?
Last year was April 1st, so it's usually around then.
Plus materials still cost something, or is that not on?
Yeah. So for stuff we did get a quote for, we just do MSRP, and we get, you know, 75% of that.
In my case, we're going to machine the part what's that? Is that both? Should I just put the price that we bought it for?
What are we machining?
Usually the water jet is blank rotors.
Oh, the blank rotors just kind of stop. Yeah, so that's just cast iron based on the weight.
So when you have your part in the assembly, there usually is a way to just do like a stock material real quick with that part. Like not that you have to explain how to do it, but people can look it up on their own.
So SOLIDWORKS doesn't do a great job of doing bounding box. So what I usually do is, if my part is a square, I'll draw a square slightly bigger, dimension it out, and then I'll do a boss extrude, 0.04 in one way, and then I'll do offset from surface, click the other surface, and offset it 0.04. And that's a quick and easy way to get the stock. And if your part does change, modeling it in that way will change and update as well. So, but the best way is at the very bottom of your tree, just have a boss extrude that just boss extrudes the stock, the BOM stock. You can make separate configurations if you don't want it in your actual tree, but I would just go in and name that boss extrude BOM stock, so everyone knows if you're not able to get to that part, they know like that's the stock. So who's excited?
It's due April 2nd.
Okay, so April 2nd.
When you go to the website and just do a quick run through what it looks like and functions and all that.
How do I get to project, not PowerPoint? Okay, so this is what it looks like when you first log in. If you're ever here, just to get to anything useful, you click Activities menu. Yeah.
It's actually just worth mentioning. So, is this link already in the PowerPoint?
No, but I can add it.
So add the link, and then anybody who plans on doing work on this needs to submit so that we can add you to the team. And then that's how you can get to this website. And not only that, but this website is where we ask our rules questions. It's also where we get all our official documents for the competition, and it's also where we submit all of our documents. So any other document that we submit for anything, we submit it through this website. So make sure you do that if you plan on working on the BOM.
So how many of you have seen this before? Yeah, this website before.
How many do not?
Okay, so that's a good portion of you. So make sure I'll add this in the PowerPoint at the end, the link to this. Make sure you sign up. And then when you do, request to be a member of both teams. So you can see the IC car one and you can work on the EV car one. So again, here we go to the online cost report system. And as I was saying, at the bottom of every page, here is all the lists. So if we go to materials, there's tons. I think there's like 900 different things in here. You can search here. So if we want, there's our shocks that we added. And then let's say you're working on composite stuff. There's, you can search by category. If you're looking for specifically an AEM ECU like we have on the IC car, you can search there for supplier. So again, all raw material is in here. So for each raw material, you can do it by dimensions, which is kind of harder. because it asks for an area, so you have to calculate the area when you could just have SOLIDWORKS do the maps properties for you. But I mean, it's there. So we got raw material for aluminum, brass, and just down, 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 tons. So if something we bought in your sub-team is not in here, we need to fill out that form and submit it as soon as possible.
Just for reference, Kyle said it takes 1 to 2 weeks. We have 4 weeks until this is due. So you need to do that by.
And again, the bought parts are easy to do if they're there. We can go to fasteners. Here's all the fasteners. So, you know, it just has bolt grade 12.9. That's pretty much the bolt we use for everything. And if you go in here, you can see that it's going to ask for length here and diameter here. And yeah, and you fill that out, it gives you a cost. And this is what I mean by, you know, crazy formulas that make no sense. So that's how it calculates the cost of each bolt. And before, we'd have to actually type out a lot of those formulas into the Excel sheet. So again, you guys are lucky. We have the processes tab. So I mean, there's tons of different processes as well. And if we go here, these are the process multipliers in this column here. So there's assembly processes. We go down to machining. You know, it'll tell you exactly which multiplier to use for each process you have. So you need to go into the process multipliers and make sure that you are, you know, putting the correct multiplier. Machining aluminum is 1, so you know it doesn't affect the cost, but you need to put it in there. Otherwise, we can get marked down points for not specifying the machined aluminum. So process multipliers. This one's pretty short. You know, most of it's machining. There's some assembly stuff, some fastener installation stuff, and some drilling and tapping. Last one is tooling. So really the only ones that we do are lamination. So this is for the composites team. So we have the lamination flat panel tool, and lamination mold tool. If we see here, it's, you know, square meters, so surface area of the actual mold. And then welding fixture. So anything that is accurately welded gets a welding fixture. So this is control arms, this is chassis, probably like the battery brackets, and I think that's it. But when we go in here, you can see it's $500 per point. So that's a lot. But that's not the cost that goes into one car, because we use this tooling for, you know, 1,000 cars. So I think it's in the rules exactly how much. So I don't know the number, but we divide this cost divided by, let's say, 1,000. So instead of $500 a point, it's, you know, 50 cents. So it's not as bad as it looks, but that's the general gist. If we go to manage the vehicle, you know, here, brake system, and if we want to say, you know, like, you know, we have to create each sub-assembly that goes in this assembly. So we're going to create this assembly and open it. We're going to add a part. And then to get into this, you can open part here, and now you're in the part component. For this one, it was pretty easy. You we go and we look for the, so here it says not applicable, so it's just the cost of the bought part. We click save, and if we go back to system assemblies, we can see that it automatically updated this assembly for the brick calipers. So again, it's not super hard, it's really tedious, and difficulties come when you're just not prepared for it. So, anything else? Okay, well, I wish you guys the best. I'll be around if anyone has questions.
Yeah, you want to do that right now?